Assalamualaikum students. Dear student, I'm your teacher, Zeenat, and we are doing covalent bonding in this recorded lecture. You know what is covalent bonding? The bond that is formed by mutual sharing of electron between non-metal atom. Can you repeat with me? The bond formed by mutual sharing of electron. You know what is the meaning of the term mutual? Like if one atom is sharing one electron, the other is also sharing one electron. If one is sharing two electrons, the other is sharing also two electrons. But why they share electron? To complete their last shell, outermost shell. Atom can complete their last shell either by loss of electron, by gain of electron, or by sharing of electron. The loss of electron and gain of electron is done by metal and non-metal. See, this lose electron, they gain electron, it lose electron, it gain electron. Now it loses and it's gaining. This is what ionic bonding. See, the metal lose, the non-metals gain, right? In ionic bonding, the metal lose, the non-metal gain. Incovalent, which is possible between non-metals. They share electron, they share. But you know why they share? To complete their outermost shell. So the bond which is formed by mutual sharing of electron, the bond in which there is electrostatic force of attraction between cation and anion, the metal lose electron, they make cation, the non-metal gain electron, they make anion, complete transfer of electron occurs, ionic. But sharing of electron, covalent, right? So, if I explain this to you, look, on a separate page, wait a minute. Like this. Look. You know how they share electron? Suppose if I take oxygen, it's of group 6. You know what is happening? Oxygen and hydrogen, how they will complete their last shell. Or for example, if I take carbon, nitrogen, oxygen, fluorine, look, carbon, group 4, carbon is of group 4. So carbon is of group 4, 1, 2, 3, 4 electron in the outermost shell. Nitrogen, group 5, 1, 2, 3, 4, 5 electron in the last shell. Oxygen, group 6, 6 electron, 7 electron. So if I draw carbon, for example, this is carbon, this is nitrogen, this is oxygen, and this is fluorine. And for instance, this is the neon, I think. Look, carbon, 1, 2, 3, 4. Nitrogen, 1, 2, 3, 4, 5. Oxygen, 1, 2, 3, 4, 5, 6. Fluorine, 1, 2, 3, 4, 5, 6, 7. Neon, 1, 2, 3, 4, 5, 6, 7, 8. Complete and reactive, because it will neither lose nor gain nor share. So it needs how many electron to complete? 4. It needs how many electron to complete? 3. It needs how many electron to complete? 2. It needs how many electron to complete? 1. So they can gain electron in ionic, but they can also share. Suppose there is this hydrogen. Like I'm going to draw these twice, especially these. I'll tell you why. Suppose this is hydrogen. Having how many electrons in the last shell? Just one. Need how much? One to become like helium. Because hydrogen has first shell, which is the last shell. The first shell of the hydrogen is the last shell too, because it's just one shell. And what is the capacity of the first shell? 2 electrons. So it will gain one, 2. If they share this electron. Oh, I made a mistake. I'm going to draw it again. Wait a minute. This is the hydrogen. Having one. Now see, it can share this. This way. What I'm doing. Oh, okay. Hydrogen, another hydrogen, another hydrogen. Look, this hydrogen sharing one, this hydrogen sharing another, this hydrogen sharing another. So this way. Carbon is having 1, 2, 3, 4, 5, 6, 7, 8. So is carbon sharing one with one bond, two bond, three bond, and four bond? Is this CH4? Yes. This is what CH4, methane. Now, exactly if nitrogen sharing 1, 2, and 3, each hydrogen, look, carbon, 4 elements, so 4 hydrogen, nitrogen, 1, 5, so it needs how much? 3. So 1 hydrogen, 2 hydrogen, 3, it's what? NH3. NH3. What about oxygen? 1 hydrogen. And another hydrogen. So it's what? H2O. Is this H2O? Like there are 2 hydrogen. This bonded to oxygen. This also bonded to oxygen. So HOH. Just nitrogen with 1 hydrogen, another hydrogen, another hydrogen. So it's what? CH4. It's what? NH3. It's what? H2O. C. CH4. NH3. H2O. Now this one, look, how many hydrogen needed? Only 1. So 1 hydrogen. Does it need anything? No. So if you see, it needs how many hydrogen? 4. So it would be like this. CH4, SiH4, NH3. They need you need 4 hydrogen to complete. They need 3 hydrogen. They need 2 hydrogen. They need 1 hydrogen. So see, it's what? HF, HCl, HBr, HI. It's like this. It's what? H2O. It's what? H2S. It's what? It's what? H2SE. NH3, PH3. See? Now, you know hydrogen makes how many bond? 1. Is there any group in the periodic table that also make 1 covalent bond? Yes. You know which group? Group 7. Look, for instance, if I bring 4 chlorine, this is 1 chlorine, another chlorine, another chlorine, another chlorine. You know why? Chlorine, group 7. Chlorine has, or fluorine, like you can say chlorine or fluorine, both, Chlorine or fluorine? They have how many electrons? They're of group 7. They have 7 electrons in the last shell. They need how much? Only 1. So if they need 1, they will share 1. Like carbon need 4, so share 4. Carbon is sharing how much? 4. Nitrogen need 3, so share 3. Oxygen need 2, will share 2. So if this is chlorine, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So is this mutual sharing of electron? Yes. Mutual sharing. How many chlorine are needed for this? Definitely 3. NCl3. Look. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And how many chlorine? 2. One, two, three, four, five, six, 7. 1, 2, 3, 4, 5, 6, 7. So this is what? CCl4. This is what? NCl3. This is what? OCl2 or Cl2O. Both are correct. And chlorine with another chlorine. C, definitely the same way. Look. Wait a minute. If an element need 1 in a covalent, it will share 1. If it needs 3, share 3. If it needs 2, share 2. Like the group 4 elements, they need 4, they will share 4. Group 5 need how much? 3, they will share 3. Group 6 need how much? 2, they will share 2. Now, look, I'm telling you one thing. We are starting with oxygen. This is oxygen, group 6. Oxygen is of group 6. 1, 2, 3, 4, 5, 6. See, this is 1 oxygen. Now I'm doing, what is this? This is 1 oxygen. This is another oxygen. And I'm drawing another oxygen too. Wait, you will think that why? Look. If you see these 2 oxygen, this need how much? 2. And this also need 2. Now, this need 2, the other also need 2. So how they can help each other to complete their last? This also need 2, this also need 2. They will share 2 with each other. How? Look. This is oxygen. 1. This is another oxygen, the red one. This is oxygen. This is oxygen. It will share 2. 1, 2, 3, 4, 5, 6, group 6. Now, this one. 1, 2, 3, 4, 5, 6. This is sharing how much? 2. This is also sharing how much? 2. So how much are shared? Total 4, each 2. So 1, 2, 3, 4, 5, 6, 7, 8 complete. 1, 2, 3, 4, 5, 6, 7, 8 complete. So oxygen is sharing. This is blue. Sorry. This one is red. So they are sharing how much with each other? Looks so artificial. Huh? This should be like this. Like circles does not suit to oxygen in this case. So they're sharing two. So if they're sharing with each other, they're going to make a double covalent. But if the same oxygen, see, is making bond with, no, not this, what I'm doing, the same oxygen with two hydrogen. So hydrogen can make how many bonds? Just one. Or group 7 even. Like, look, hydrogen, H2O, group 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Chlorine. This is what? H2O. This is what? Cl2. It's perfect. Now taking another example. Suppose we have nitrogen. Exactly in the same way. Nitrogen. This is suppose nitrogen. 1, 2, 3, 4, 5. This is one nitrogen. I'm going to draw the nitrogen many times. Look, this is one nitrogen. This is another nitrogen. And I'm going to draw it again to show. Now, look, if this nitrogen need how much? 1, 2, 3. This also need 1, 2, 3. What they will do, how they can help each other by making triple covalent bond. It will share 3 with each other. How? See, this is one nitrogen. And this is another nitrogen. What is this? This is another nitrogen. This one is sharing how much? 1, 2, 3. How much is it left? 2. And what about the other one? Same. 1, 2, 3, 4, 5. So between the two nitrogen, there are triple covalent bond. But if you look at the electrons, 1, 2, 3, 4, 5, 6, 7, 8, and 6, 7, 8. So each has complete. So it's mutual sharing of electron between non-metal atom to complete the last shell. Now, if the same nitrogen is making bond with 3 hydrogens, because hydrogen can make just one bond. 1 hydrogen, 2 hydrogen, 3 hydrogen. Hydrogen is what? NH3. And there is possibility of any group 7 element. Any group 7, chlorine, bromine, NCl3, NBr3, it's like this. So it's suppose Cl. It's suppose Cl. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8, 8, and 8 too. So what is covalent bonding? Mutual sharing of electron between non-metal atoms. See, if there is chlorine with another chlorine, in the last shell, 1, 2, 3, 4, 5, 6, 7, another chlorine, 1, 2, 3, 4, 5, 6, 7. See, single covalent bond, perfect. So what is covalent bond? How you will define covalent bond? The bond formed by the mutual sharing of electron between non-metal atom to complete the last shell. Now there is another situation. If I share the notes with you, see this covalent bonding. The bond formed by mutual sharing of electron between non-metal atoms. There are 2 types of structure. If we study like in ionic, there is what? Only one type of structure. That is what? Giant ionic lattice. Regular arrangement of alternating cation and anion. Now, in covalent, there are 2 two types of structure. Huh? There are two types of structure, and the structures are what? Giant molecule and charging is wait. In covalent, there are two types of structure: small simple molecules or giant molecule. You know what is the difference? In simple molecule, there is one covalent, there is this one covalent in CH4, look, just 4 covalent, H2O 2 covalent, group 7 1 covalent, NH3 3 covalent, and this is double covalent, this is carbon dioxide, ethene, this I'm going to discuss, wait a minute. If you see, what is the difference between giant and covalent? Like if there is water, in one water, how many covalent? 2 covalent. In one CH4, how many covalent? Just 4 covalents. And what you can see here, 1 covalent, 2 covalent, or millions of covalent. Millions of. This is a network of covalent. This is a network of atom, network of covalent. The atoms are bonded. It's a giant molecule, a big molecule, and a small molecule. Small molecule and a big molecule. You know, every diamond is a big molecule. Graphite is a big molecule. See, it's a graphite. Silicon oxide is a big molecule. You know what is the difference between giant and simple? In giant molecules, there is covalent, covalent, and covalent bonds. When you melt it, covalent break, covalent break, covalent break. But in simple molecule, they're just small molecules. Inside the molecule is covalent. But between one molecule and another molecule, there are what? Intermolecular force. In giant, there is no intermolecular forces, just covalent. But in simple molecules, see, simple molecules like H2, O2, N2, steam, they are all simple molecules. In air, there are molecules. One molecule attracts another molecule with very, very weak forces, which are called what? Intermolecular. What is the meaning of the word inter? Between molecules. Like one molecule and the other molecule, between molecule, intermolecular. In giant molecule, look, what is the difference? Simple molecules have weak intermolecular forces which are responsible for low melting and boiling point. They are weak. But in giant molecules that I'm going to describe in detail, right? Giant molecules have network of strong covalent bonds that need a lot of energy to break. Covalent is a very strong bond, right? When you boil water, see what is happening. Wait a minute. Let me explain this to you. For example, this is a container. Inside the container, this is one water. Let me draw it properly. Wait a minute, so that you can understand. This is 1, 2, 3, 4, 5, 6, and this is this. One water. I want to draw it neatly, a bit neat, because I know you people like neat work more. No, not this. My one side of the beaker is long. Yeah, it works, I think. Not very good, but okay. This is one water molecule. Another water. Very close. Another water. Another water. Another water. Wow. Like this I like about iPad. Look. Wow. These are water molecules. Not very regularly arranged because in liquid the particles are close but not ordered. In solid, they are closed and ordered arrangement. So what is the difference? Look, in liquid, the particles are close arranged but not ordered. In solid, they're closed and ordered, right? So I don't want to give order, but I think there is order in my drawing. Sorry for this. My water molecule is even a bit out of the beaker, but it's okay. So these are water molecules, right? They're closely arranged, but they're not regular. So when I will heat water, you know what will happen? The water's molecules, the water molecule are getting far apart. Huh? They are getting far apart. Are the water molecule breaking into atoms? No. Look, when you heat it, the molecule were attracting strongly each other. Their intermolecular forces are strong. The intermolecular forces are getting weak. Heat overcome intermolecular forces. Have you ever heard that after heating, you are collecting oxygen gas just from water? Like you break the water into hydrogen oxygen? Not at all possible. You can't just boil water into oxygen hydrogen. अगर तुमने पानी हीट किया, पानी से ऑक्सीजन हाइड्रोजन बने, तो बहुत आसान हो जाएगा. पानी उबालो, हाइड्रोजन बनाओ, ऑक्सीजन बनाओ, गाड़ी चलाओ, हाइड्रोजन जलाओ. सॉरी, तो गाना बन गया. तो ठीक है, you boil the water and you get oxygen and hydrogen. The oxygen that is used in hospital in oxygen tanks, in COVID, the oxygen was used. लोग पानी तो नहीं उबालते थे ना, स्टीम करने के लिए उबालते थे. But पानी उबाल के ऑक्सीजन नहीं बनता. You can't break the bond. You can do electrolysis. You will pass electricity. You can break the bond there, right? But otherwise, you can't break the covalent bond of the water. When you heat water, you make the molecule to go far apart. You can't break the molecule. You can't break the covalent. You can break the intermolecular forces because they are weak. So in the simple molecules, the covalent does not break, but break intermolecular forces on boiling and melting. Therefore, simple molecules have low melting and boiling point. But in giant molecules, when you melt them, the intermolecular forces don't break. They don't have intermolecular forces. They have covalent bond. In giant molecule, there are only covalent bond that will break and need a lot of energy. But in simple molecules, when you are hitting a simple molecule, the intermolecular forces will break. Do you understand this? Huh? Now, therefore, they have low melting and boiling point. They have low density, right? And second, they don't conduct electricity. Why? Because they don't have delocalized electrons. Their electrons are all bonded, they're fixed. The electrons are not free to move like metals, like graphite. They don't have delocalized electron and they don't have ions at all. They don't conduct electricity. Now, if I go to the notes, see, the covalent bond, the bond formed by the mutual sharing of electron between non-metal atoms, They could be simple molecule, they could be giant molecule. In giant, there is network of covalent bonds. They are big molecules, they need a lot of energy to overcome. But in simple molecules, there are weak intermolecular forces. They have low melting and boiling point, low density, they don't conduct electricity. Why they have low melting and boiling point? Because of weak intermolecular forces, and they don't, like, these are your answers, nothing else. Right? Why I'm giving you the notes? So that to write what is required. Okay, so for the dot and cross diagram, these are simple, this we have done. Yes, if you see carbon dioxide, this is very repeatedly asked. Oxygen I have explained in detail. In carbon dioxide, if you see, this carbon is of group 4, need how much? 4? 1, 2, 3, 4, so they need further 4, right? And group 6 need how much? 2 and 2. So this need 4 electron need 2 electron to become 8, need 2 electron, right? Now what they are supposed to do? It will share 2 with this and 2 with this. So if it shares 2 with this and 2 with this, so it's going to share 4. In turn, they're also sharing 2. See, the carbon. Carbon, oxygen, and oxygen. Carbon 1, 2, 3, 4. Oxygen 1, 2, 3, 4, 5, 6. 1, 2. Another oxygen 3, 4, 5, 6. So is this carbon making total 4 bonds? Yes. 1, 2, 3, 4. This is oxygen is making 2 bonds. So the last shell is complete of carbon. Yes. Why? 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. I hope you understand. If you have any problem, you can talk to me, you can contact me, you can get all the information on my website, Chemistry by Zeenat. Don't forget to like and subscribe my channel. In the next lecture, I'm going to do giant molecule with you people, and see you in the next lecture. Bye. Allah Hafiz.